Hello friends, welcome to CS Tunes. In our last video, we have discussed about the conversion of context-free grammars to pushdown automata. In this video, we are going to learn the conversion of pushdown automata to context-free grammar. Before going into the details of the conversion, let's define the pushdown automata and context-free grammar in mathematical form. Mathematically, pushdown automata can be represented using 6 tuples. The first tuple, capital Q, is a non-empty finite set of states. Second tuple, summation, is a non-empty finite set of input symbols. Third tuple, gamma, is a finite set of pushdown symbols. As we have already discussed that a pushdown automata has some extra storage space, that is in the form of a stack, and for that stack we are having gamma, which stores the symbol of the stacks. Next tuple, capital S, is the initial state or the start state, and start state belongs to the set of state, that is capital Q. Then the next tuple, capital F, is a set of final states, and F is a subset, or it can be equal to the set of states, that is capital Q. Now, delta over here is the transition function or transition relation. To convert it to a CFG or context-free grammar, we must understand what exactly is a context-free grammar. So a CFG can be represented using 4 tuples. The first tuple, Vn, is a finite set of non-terminals. That means they are variables and its value can be changed. The second tuple is Vt, that is a finite set of terminals. Terminals are constant and their value cannot be changed. Then S is the start symbol of the grammar and S belongs to Vn. That means S belongs to the set of non-terminals. Then the next tuple is our P, and P is the set of rules for the grammar and is known as production rules. So in case you are not clear about the PDA, pushdown automata, or context-free grammar, you can go back to our videos in which we have discussed about the pushdown automata and context-free grammars in detail. Now, let's start with the conversion of the pushdown automata to context-free grammar. Before conversion, we have to assume two things. First of all, let us assume that the stack bottom is indicated by a symbol $. That means we are saying that in the bottom of our stack there is a symbol that is a $. The second assumption is that let capital S be the start symbol of our grammar. That means for our grammar we are going to start it with a symbol capital S. Now, these are the steps which has to be followed in order to convert a pushdown automata to a context-free grammar. So, there are 3 steps. Let us discuss them one by one. According to step number 1, for every state Q belonging to capital Q, that means the set of states, we have to add a production S tends to Q naught $Q in P. Dollar, as we have said that dollar is the symbol which is present in the bottom of the stack. So for every state in your pushdown automata, you need to add a production which is of this particular form. So here S is your start symbol for your grammar, then Q naught is your initial state, $, and Q in the productions for your grammar. Productions is represented by P, as we have already discussed. Now, let us see what does it mean. Suppose in your pushdown automata there are 2 states, for example Q0 and Q1. So you are going to add 2 productions. The first production will be S tends to Q0 $Q0. and the second production will be Q naught dollar Q1, because Q naught is the initial state that is kept as constant, and Q over here is changing, and it is taking the value of all the states that are present in the set Q. So that means for a pushdown automata in which there are two states Q0 and Q1, you are going to have two productions of the form S tends to Q0 dollar Q0 and S tends to Q0 dollar Q1 in the production rules for your grammar. So by this we have understood that if there are n states in a pushdown automata, then there will be n number of new productions in the production rules of our grammar. So for every state there will be a production rule. That means for n states there will be n production rules. Now, let's see the second rule. So, the second step states that for every state Q, comma R. So, these are two distinct states. First state is our Q and second state is our R. That belongs to the set of state that is Q. And A belongs to summation union epsilon. That means A is our input symbol because A belongs to the set of input symbol that is summation, or it can also be null. That's why we have written over here summation union epsilon. And X belongs to gamma. X belongs to gamma means X is the symbol of our stack. So from here, what we mean is that for every state Q, comma R, that means we are talking about two states from the set of states Q and an input symbol A and a symbol of the stack that is X. If this type of a production is, if this type of a transition is present in our pushdown automata, then we need to add this production in our production rules. Now let us see what does this mean. Suppose we have a transition of the form Q is the current state, A is the input symbol and X is on the top of the stack, equals to the next state R. That means we are moving from state Q to state R, and the symbol on the stack that is X is replaced by a epsilon. That means we are popping the element X out of our stack. So in case of the pop operation, what we need to do is that we need to add a production of the form Q, X, R tends to A in the grammar. That means the state Q which is present over here, we need to copy it as it is over here. Then the stack top which is as X, we need to copy it over here. Then the state which is present on the right hand side of our transition, we need to write it over here. And it tends to the input symbol which we are providing. So this is our production. Now over here from these steps, one thing is clear that these have to be learned. In order to solve the question on the conversion of pushdown automata to the context-free grammar, you need to learn these steps. Now, the second thing is that you are going to apply these steps for the conversion purpose, for the conversion of the pushdown automata to your context-free grammar. Now let us see the third step. According to the third step, suppose Q comma R belongs to capital Q. That means you are having two states Q and R. And A is the input symbol that belongs to the set which is union of summation and epsilon. And X belongs to the set gamma, that means it is on the top of the stack. And also one condition is there, X should be greater than equal to 1. Suppose this condition is satisfied and there is a condition provided like this. Means there is a transition rule of this particular format in our pushdown automata. Then we have to add multiple productions of this format. Now let's discuss how can we achieve it. Now over here for the transition, this is, if we see it properly, it is our push operation. So in this step we were talking about pop operation, and in the third step we are talking about the push operation. How is it push operation? You are at a state Q, the next state will be R. The input symbol is A, and on the top of the stack there is a symbol X. Now, X is replaced by n number of symbols. That means you are replacing xy, x0, x1, x2, so on till xk. That means you are pushing the elements into your stack. So for the push operations, what you are going to do is that just copy your Q over here as it is. Then the next X is copied here as it is. So the first state is here, and the top of the stack is copied as the second symbol, and then the A has to be written on the right hand side of your production. Now here QK, we have to assume this production for all the states present in the set Q. So you are going to assume for all the states. That's why I have told you that there will be multiple productions, as you are going to have multiple states in your pushdown automata. So one thing is clear, that Q has to be copied over here, then X has to be copied over here, and then A is on the right hand side of your production. Then the next state R has to be copied over here as the first state. Then you will take all the input, all the stack symbols, x0, x1, x2, so on till xk. That means all the stack symbols which are present on the right hand side of your transition, you are going to take it on the right hand side of your production rule also. Now over here, one thing is to be noted, that QK, the state over here, has to be written in the last of the production. So this QK has to be same over here. Similarly, one more thing has to be noted is that the ending state of the first production is the starting state of the next production. So you have to keep it in mind that the ending of this is the starting of this. So as you can see over here, I have used different colors. So these different colors is to signify that the same color means you have to write it over here. Because Q is in the blue color, so you need to replace it over here as it is in blue color. Then A has to be replaced over here. Then X has to be kept here. Then R is here, and QK is same as QK. So the same color symbol represent the same value and has to be put in this way. Now this production rule is little bit complicated, and you can understand it only once you are solving some problem. So in our next video we are going to discuss that how can we solve a particular problem. From there you will be clear about all these steps and there will be no doubt left. Now one thing I would like to tell you, that over here we are writing QXR. So you are not able to understand what does this means exactly. So it is nothing else. It is only a single non-terminal. That's why we are represented it using the square brackets. You can replace it by any variable XYZ in the capital letter. So this in the square bracket is a non-terminal which is on the right hand side or left hand side of your production rule. Similarly, this is also your single non-terminal. So these are your non-terminals that are represented inside the square brackets. Thank you for watching our video. For further queries, please leave the comment in the comment section below. Stay tuned for more videos and do like and subscribe our channel CS Tunes. Thank you.